This video we're going to discuss Dalton's law of partial pressures, which is a very simple idea, but it's very difficult for some students to grasp. It's the fact that the gases in a mixture, they have interactions with the wall that are independent of all the others. So each gas is going to contribute to the pressure on that wall, and the total pressure is simply the sum of the individual pressures from each of the gases. So for example, if you look at the pressure of the air at sea level, it's 1 atmosphere. But since the air is about 80% nitrogen, the pressure of the nitrogen is 0.8, or 80% of 1 atmosphere. Oxygen will be 20%, or 0.2 atmospheres. Of course, this has very important ramifications, because if you go somewhere else where the pressure is a lot lower or a lot higher, then the partial pressure of oxygen is going to be either a lot higher if you dive deep in the ocean, or it's going to be a lot lower if you go high in elevation where there's less air. And so there's basically a limit above which you really can't hike Mount Everest without an oxygen tank, because the partial pressure of the oxygen up there is so low. It's not that the ratio of oxygen to nitrogen is any less. It's still 20% oxygen up there. It's just that the total pressure is so low. Down deep in the ocean, you start to experience two problems. One is if you have too much oxygen, you kind of get a little loopy. And then high pressures of nitrogen will dissolve nitrogen in the blood. And when you come back up, if you come back too rapidly, then the nitrogen comes back out of the blood as tiny bubbles, and that gives you a phenomenon called the bends. All right, so I'm just going to do a couple of little problems. Let's say we have a container of gas at a total of 5 atmospheres. Well, if the gas is all nitrogen, then the pressure of the nitrogen is just 5 atmospheres. Let's say we have 5 atmospheres total pressure, and it's a mixture of 0.4 moles of oxygen and 0.6 moles of helium. Well, 0.4 is 40% of the total number of moles. And so 40% of 5 atmospheres will be 2 atmospheres for the pressure of O2, and the pressure of the helium will be 60% of 5, which is 3 atmospheres. And of course you can see that 2 atmospheres and 3 atmospheres simply add up to the total of 5 atmospheres. All right, that's it.